Welcome guys to another video. Today I'll be discussing to you guys about the quotient rule, which will allow you to easily find the derivative of two differentiable functions divided by each other. So let's get started. So let's say we are asked to find the derivative of, and then let's say we're asked to find the derivative of f of x divided by g of x. So in order to find this derivative, what we'd have to do first is take g of x multiplied by f prime of x, also known as the derivative of f of x, minus f of x times g prime of x, also known as the derivative of g of x. And we divide all of this over, and I'll just set it up, over g of x squared, or to the power of 2. So if we're asked to find the derivative of f of x over g of x, we would get g of x times f prime of x minus f of x times g prime of x, all divided over g of x squared. So this is actually a saying that can help you remember this, and I'll show it right here. Low d high minus high d low over low squared. So I'll just bring it up here to make it easier to see. And right there. Low d high minus high d low over low squared. So if you couldn't tell already, low is equal to g of x, high, the d high part, d high is equal to the derivative of f of x, so f prime of x, high is equal to f of x, and d low is equal to the derivative of g of x, so g prime of x. Take a moment to copy all of this down in your notebook or flashcards or whatever. This is going to be very important later on, and we'll see some applications of it. So take a moment to copy this down. Okay, so once you've copied it down, let's try some practice problems now. So for our first practice problem, we have h of x equals x squared plus 2 all over 3x minus 1. So let's say we're asked to find the derivative of it, so h prime of x. So then what we could do here is apply the equation that we learned from above. And then I'll use the saying here. So what we have to do first is find the low. So low, which is in this case 3x minus 1. So I'll write in parentheses 3x minus 1. And then it goes low d high. So d high stands for the derivative of the numerator. So in this case, it's the derivative of x squared plus 2. And knowing the derivative rules, we know that the derivative of this is 1. And then we have to minus. And then it goes low d high minus high. So then high in this case is x squared plus 2. Because high refers to the numerator, x squared plus 2. Low d high, so low d high minus high, and then it goes d low. So in this case, we have to find the derivative of the denominator, 3x minus 1. And knowing the derivative rules, that would be 3. And then put this all over, and then it goes low d high minus high d low all over low squared. So then we would just take low, which is 3x minus 1, and then we square it. So if you're taking AP Calculus, you don't actually have to simplify this because they're not testing to see if you can simplify or not. But for the purpose of this video, I'll simplify it a little. So this would end up being 3x minus 1 minus, and I'll write this in parentheses, 3x squared plus 6. And then we don't need to simplify this at the bottom or expand it actually. So we'll just leave it as 3x minus 1 squared. And this up here can be rewritten as negative 3x squared plus 3x. And then it would be minus 7. And then we'll do 3x minus 1 squared for the denominator. So this right here should be the answer you get if you simplify it. Okay, let's try our next practice problem here. So for our next practice problem, we have h of t equals sine of t over t to the cubed. So I want you to try this problem by yourself. Find the derivative of h of t. And then take a few minutes to figure that out, and when you're done, come back to the video. Okay, so I'm assuming that you paused the video and did this, but if you didn't, here's how you would find the answer. So you take low, so low is t cubed in this instance, t cubed, and then you take d high, so you take the derivative of sine of t. So the derivative of sine of t is actually cosine of t. And you subtract. And then what you do next is it goes low, d high, minus high. Sine of high, in this case, would be sine of t. Sine of t. And then subtract it again, or take another one. And then it would be low, d high, minus high, d low. So in this case, we have to find the derivative of t cubed. And then knowing the derivative rules, we know that that is 3t squared. So then this would all be over low squared, which in this case is t to the cube. So let's write that. And t to the cubed. And then again, we can simplify this, but on the AP test, just know that they aren't testing you to simplify it, so you can leave it like this if you want to. So for purposes of the AP exam, I'm just going to leave it like this. So now we have our next practice problem here, where we are asked to find the derivative of tangent of x. So in order to find the derivative of tangent of x, first let's rewrite it. So I'll just rewrite it like this, d of x. And then tangent of x can be rewritten as sine of x over cosine of x. Actually, I'll write it in colors so it's easier to differentiate or to differ between them. Sine of x over cosine of x. So I want you to find the derivative of this. Take a few minutes to figure it out and pause the video and unpause the video when you think you have the correct answer. Okay, so in order to find the derivative of sine of x over cosine of x, what we do here is we can use the quotient rule that we discussed earlier, because it's just sine of x over cosine of x. It's pretty much the same as f of x over cosine of x, except f of x is sine of x and g of x is cosine of x. So let's solve this. So we can set this equal to, low d high minus high d low over low squared. So let's start with the beginning. Low, so that's cosine of x. Low d high, so that's the derivative of sine of x. So that would be the derivative of sine of x is also cosine of x. And then minus, and then it's low d high minus high, so high is sine of x. High, and then d low would be the derivative of cosine of x, which in this case is negative sine of x. And then we would divide this all by g squared, which in this case, or low squared actually, which in this case is cosine of x. So then that can be written as cosine of x squared. So if we were to simplify this, well, actually, again, there's no need to simplify this if you're taking AP Calculus, unless your teacher says to or the test says to, but most of the times it won't tell you to simplify it because, again, they're testing your calculus skills, not your simplification skills. But if you were to simplify it, we would end up somewhere along the lines of here. Cosine squared of x plus sine squared of x over cosine squared of x. And then using our trigonomic identities, we know that cosine squared of x plus sine squared of x is equivalent to 1. So then this would just be 1 over cosine squared of x. And then 1 over cosine squared of x is the same thing as secant squared x. Okay, now let's try to evaluate our next one. So they want us here to evaluate the derivative of cotangent of x. So if you don't remember, cotangent of x is the opposite of tangent of x. So you just flip the numerator and denominator around. So in this case, we can rewrite it here as d dx. And then it would be cosine of x. Here, I'll write it in blue again. It'd be cosine of x over sine of x, instead of the other way around where tan of x was sine of x over cosine of x. So I'll give you 2 minutes to try to solve this. Pause the video when you think you're ready and unpause the video when you want the answer. Okay, so I assumed you work on it, and I'll solve the problem now, or I'll show you how to get there. So low d high minus high d low over low squared. So low, in this case, is sine of x. Low d high. So high would be the derivative of cosine of x, which in this case is actually negative sine of x, minus, and then high, which is cosine of x, times, and then it would be low d high minus high d low. So the derivative of the denominator, sine of x, would be cosine of x. So cosine of x. and this would all be over this would all be over sine of x squared. Okay, now that we know that, we can simplify this a little. So we can simplify this to be negative sine squared of x minus cosine squared of x over sine squared of x. So then here we can actually rewrite it as negative sine squared of x plus cosine squared of x over sine squared of x. And then this is equivalent to sine squared of x plus cosine squared of x, which we know from our trigonomic identities that is equivalent to 1. So this would be negative 1 over sine squared of x. And then this is equivalent to negative cosecant squared of x. Okay, so then there's just one more right here, or there's two more actually. So here we're asked to find the derivative of secant of x. So then if we were to find the derivative of secant of x, we could rewrite secant of x as d over dx. And then secant of x is the same thing as 1 over cosine of x. Oh wait. And cosine of x. Okay, so pause the video here, take a minute or two to try to figure out the derivative of secant of x, and unpause the video when you're ready for the answer. Okay, so I assumed you did the problem, but if you didn't, here's how you would do it. So you take the low in this case is cosine of x. Then you take the derivative of 1, which is 0. Then you subtract that by high, which is 1. And then you take the derivative of the bottom, aka low. So the derivative of cosine of x is negative sine of x. So let's do that. Negative sine of x. And this is all over cosine squared of x, or cosine of x to the power of 2. So for time purposes, let's say we simplified all of this, we would get sine of x over cosine squared of x. So that would be how you do it, but we could stop there or we could keep going. If we want to keep going, we could actually write this as sine of x over cosine of x and times 1 over cosine of x. And this right here can be rewritten as tangent of x times secant of x. So then tangent of x times secant of x is the derivative of secant of x. Okay, so we have one more here where we're asked to find the derivative of cosecant of x. So if we want to find the derivative of cosecant of x, we can rewrite this like we did the rest. So can rewrite this as 1 over sine of x. Just like that. Except, let's make it color-coded. Sine of x. Just like that. Take a minute or two to try to solve this one, and unpause the video when you think you have it right. Okay, so I assumed you solved it, and this is how you do it. So this would be equivalent to low. So low is sine of x. D, the derivative, d high, the derivative of 1, that's 0. Minus high, so high would be 1. And then d low, the derivative of sine of x is cosine of x. And this would be all over sine of x squared. So we can simplify this to be negative cosine of x over sine squared of x. And this right here can actually be rewritten again as cosine of x over sine of x multiplied by negative 1 over sine of x. And then this can be rewritten at the end for a final of tangent of x times negative cosecant of x. And if you really wanted to rewrite this, you could write it as negative cosecant of x tan of x. Okay, well, that's all for this video. In total, we learned the quotient rule, low d high minus high d low, and we learned the trigonometric or the derivative of tan of x, cotangent of x, secant of x, and cosecant of x. I hope this will help you with your next assignment, whether that be the AP test or your next test in class. So, if this helped you a lot, or you really enjoyed this video, please subscribe to the channel and like the video. That would help a lot. Okay, thank you. Goodbye, guys.